All right, geometry students, we're continuing with our progression in writing proofs. Very important that you guys are studying these postulates here. Going forward, everything we do is in a logical sense. We're going to be proving statements, whether they're true or false. So postulates in geometry, a postulate is a statement that is accepted as true. Postulates describe fundamental relationships in geometry. So these statements are true. So we need to learn them. We need to memorize them. Do what you got to do. So postulate 2.1, through any 2 points, there is exactly one line. So you only have, when you're given 2 points, there's only one line that connects them. There is no more than one line. There is exactly one line. Postulate 2.2, through any 3 non-collinear points, there's exactly one plane. So if you have 3 points that are not in a line with each other, there is exactly one plane that holds all 3 points in that plane. 2.3, a line contains at least 2 points. So a line in order for there to be a line, there has to be at least 2 points that connects them. That's it. A line contains at least 2 points. 2.4, a plane contains at least 3 non-collinear points. So a plane, in order for there to be a plane, there has to be at least 3 non-collinear points. So they can't be in a line with each other, and there has to be at least 3 of them. 2.5, if 2 points lie in a plane, then the entire line containing those points lies in the plane. So if there's 2 points within one plane, the line that contains those 2 points is also in that same plane. 2.6, if 2 lines intersect, then their intersection is exactly 1 point. Lines intersect at points. So if 2 lines are going to intersect, they can only intersect at 1 point. So that's given 2 lines. So if this marker here and this pen here were 2 lines, they'd intersect at the 1 point right there where you can see them intersecting. They don't intersect at multiple points, just 1 point. The next one, 2.7, if 2 lines intersect, then their intersection is a line. If 2 planes intersect, then their intersection is a line. So if you had 2 planes, so this piece of paper and this calculator, if they're intersecting at a line, not a point. So planes intersect at lines, lines intersect at points. So let's look at the example. Determine whether each statement is always, sometimes, or never true. There is exactly one plane that contains points A, B, and C. So what's missing here is, do we know if A, B, and C are collinear or are they non-collinear? Because if they're collinear, then there can be a lot more planes. If they're non-collinear, then there's only one plane. So what we have is sometimes. Why? Because if A, B, and C are collinear, they are contained in many planes. But if they are non-collinear, then they are contained in exactly one plane. That's postulate 2.2. So I'll put 2.2 here for you to look at. That's postulate 2.2. But if they're in a line, so if 2 points lie in a line, then they lie in the same plane. So if they're collinear, meaning they're in a line with each other, then there's many planes that contain those points. So the answer is sometimes. Points E and F are contained in exactly one line. This is always true, because for any 2 points, there is how many lines? Through any 2 points, there is exactly one line. That is postulate 2.1. 2 lines intersect in 2 distinct points, M and N. Well, this is never. Why? Because Lines can only intersect at one point. So if two lines intersect, then their intersection is exactly 1 point. That's postulate 2.6. Now, you don't need to label the postulates on these problems here, but down the road, you will get into the habit of identifying the postulates. So let's go ahead and do some examples together. A line contains exactly 1 point. Well, that is never going to happen. That's never, because a line has at least 2 points. Every line there is at least 2 points, so that's never. Non-collinear points R, S, and T are contained in exactly one plane. Well, that's always. That's one of our postulates. Non-collinear points, 3 non-collinear points are contained in one plane. So this is always. And that's because of postulate 2.4. If you want to write down what postulate it is, you don't have to. A line contains exactly 1 point. Never. That's postulate 2.1. Any two lines L and M intersect. Well, this is, you have to think about it. We can have lines L and M where they never intersect, but we do have lines L and M where they do intersect. So this is sometimes. If points G and H are contained in plane M, then GH is perpendicular to plane M. Well, if the 2 points are contained in plane M, then the line is contained in plane M. So this is never. It can't be perpendicular because it's contained in the plane. Planes R and S intersect in point T. Notice the wording here, in point T. Well, we know planes, they don't intersect at points. They intersect at lines. So this is never. Two planes cannot intersect at a point. They have to intersect at a line. If points A, B, and C are non-collinear, then segments AB, BC, and CA are contained in exactly one plane. This is always. This is always true. And it's always true because of postulate 2.5. But notice, you don't have to give a postulate for these. You just need to tell if it's always, never, or sometimes. So I did that work for you guys. In the figure, AC and DE are in plane Q, and AC is parallel to DE. State the postulate that can be used to show each statement is true. Exactly one plane contains points F, B, and E. So F, B, and E. There's only one plane that contains those points. Well, what do we know? F, B, and E, they are non-collinear points. So if I go back over and I look at my postulates, and I will notice that through any 3 non-collinear points, there is exactly one plane. Through any 3 non-collinear points, there is exactly one plane. Not 2 planes, not 3 planes, not infinite planes, just one plane. So that's our postulate that we're going to use. So that to make this true, number 7 true, is postulate is postulate 2.2. Next one, line BE lies in plane Q. So notice, we don't have a line BE here, so I'm going to draw the line in just so that you guys can see it. But B is in plane Q and E is in plane Q. So we need to find a postulate that says 2 points in a certain plane, the line connecting those 2 points are also in that plane. So we go back over, look at our postulates. If 2 points lie in a plane, then the entire line containing those points lies in the plane. That's postulate 2.5. So that's all I had to do. Write postulate 2.5. So, all right, guys, that's your lesson for today. You guys need to watch the lesson and fill out your worksheet as well for full credit. You guys have the answers. Any questions, reach out. Thanks. Have a good day, guys.